A very good morning to everyone. Let's crack CSIR-UGC NET together. The topic of today is glycolysis. And before beginning with glycolysis, let me give a small introduction about myself. I'm Farida Bandookwala and I am pursuing PhD from School of Biotechnology, DAVD. I've done my MPhil in biotechnology um, and I've qualified MP SLET examination 2018 and I have a teaching experience of more than 10 years. Before beginning with the topic of today, we will also discuss a little bit about Unacademy. So Unacademy is one of the India's largest platform for the preparation of CSIR NET Life Science. If you are preparing with the help of Unacademy, what all things you are going to get is live classes. You are going to get structured courses, you are going to get live classes and quizzes, and you are going to get unlimited access of all the material available at the Unacademy platform. So what's the benefit of live classes? That if you are doing the class every day, you will be always in the motion of learning. You won't feel left out. Then these courses are designed in such a way that you will be completing the whole syllabus in a defined time. So the course is structured. Then for qualifying any kind of competitive examination, it is very much necessary that you should evaluate yourself every now and then. So live tests and quizzes play that role. And then unlimited access to all the videos, whichever is there in the platform. If there is one topic, there are thousands of lecture for that one topic by different faculty members in different manner. So whichever you find most suited for you or your understanding, you can just go for it. Then the free live classes are conducted on YouTube and there are special classes as well. So these are types of free classes on YouTube and on the special classes. So how you can get the access to the special classes is you just download the Unacademy learning app from the Play Store and make your account and you are good to go. And the live classes which are done on YouTube, like the class which you are attending now, this is the live YouTube class. So this is the way how free classes are conducted and you can make the most out of these free classes also. They are live, you can ask your doubts and queries in these live classes as well. Then there is this plus subscription, and how can you go for this plus subscription is you need to pay a certain amount and the amount is very pocket friendly. So by this plus subscription you can get all the 13 subjects of the CSIR Life Science in a very well systematic manner. And these 13 courses you can complete in a very small span of time, that is around 6 months, 12 months, and if you are a MSc first year student, go for a 24 monthly program so that you will have access to all the topics of MSc also. So just go for 12 monthly at least and make the most out of the videos, lectures available on the Unacademy. And then in the amount of subscription, you can still get a discount by 10% if you're using my referral code FB01. So do not forget to use my referral code, that is FB01, for getting a 10% discount. So this was a little bit about Unacademy and the topic of today, that is glycolysis. We are going to talk about glycolysis. So what happens in glycolysis, that it is the oxidation of glucose into pyruvate and lactate. Oxidation of glucose, pyruvate and lactate. This is the simplest definition of glycolysis, that glucose will be oxidized into pyruvate or lactate. Now this glycolysis, it has got some other name also, and the name is Embedon-Meyerhof pathway. Embedon-Meyerhof pathway or parenus. This is the thing. Now glycolysis, is it occurring in aerobic environment or is it occurring in anaerobic environment? So it occurs in aerobic as well as anaerobic condition. It occurs in aerobic as well as anaerobic condition both. This glycolysis. So do not forget that it can occur in both of the conditions. Now, what is the importance of glycolysis? Why are we studying glycolysis, or why it is given so much of importance? Importance of glycolysis. It is important because it occurs in all the cells of the body. Occurs in all the cells of body. The next thing about it, it occurs aerobically and anaerobically, both things. This we have just seen occurs aerobically and anaerobically. Then what else? It is the important source of energy for the mature RBCs and brain. Important source of energy for RBC. Why is it important source of energy for RBC that to mature? Because the mature RBC, they do not have mitochondria, and because they do not have mitochondria, they cannot do oxidative phosphorylation, and thus the mature RBCs, they completely depend on glycolysis for energy. What else is the importance? So another important thing is that during vigorous exercise, what happens is there is increased demand of oxygen. Increased demand of oxygen. So to make this demand fulfilled, and as there is low amount of oxygen in that particular condition, this pathway, it goes anaerobically. This pathway goes anaerobically. This pathway goes anaerobic, and oxygen is supplied to muscles. So this is how it compensates for oxygen also. Now there are some more things which is related to its importance. So another thing is the activity of glycolytic pathway is actually low in cardiac muscles. Activity of glycolysis is low in cardiac muscles. And if it is low in cardiac muscles, why are we posing so much importance on cardiac muscles? So whenever there is this heart attack, there will be low progression of heart attack. It won't be very severe because glycolysis won't be occurring. So energy is not provided anaerobically. So progression of heart attack will be slower. Progression of heart attack slow. This is the thing. The next thing is it is responsible for generation of the skeleton of various non-essential amino acids. The non-essential amino acids which are formed in the body, their skeleton is formed with the help of glycolysis. And the glycerol of fat, its backbone is also obtained from glycolysis. So responsible for generation of skeleton of non-essential amino acid. Those amino acids which are not formed in the body, they definitely need to be formed in the body, which are not procured from outside, which are non-essential, which body makes. So from where they start forming themselves from glycolysis. Non-essential amino acids and glycerol of fat and glycerol of fat. So these are some of the things. Then next, the reversible steps are there, and these reversible steps are responsible for gluconeogenesis. Like out of all these steps of glycolysis, just 3 steps are irreversible. Rest all these steps, they are reversible. So those steps which are reversible, they will be directly responsible for formation of glucose in the opposite direction, that is gluconeogenesis. Um, Reversible reactions participate in gluconeogenesis. So before beginning with any topic, we should have the idea that what is happening and why it is important. These all things, if we are having in our mind, it will be very easy for us to understand the importance of that thing and to learn that thing. So that's why I've told you all these things. Now let us talk about the steps. The steps. Yeah. So we know that glycolysis, it begins with glucose. The glucose will get converted into glucose 6-phosphate. This step is actually energy dependent. As you can see, there is addition of one phosphate group. So this is ATP dependent. And the enzyme which is participating in this case is hexokinase oblique glucokinase. Enzyme hexokinase and glucokinase, any one of them. And if I am making this thick arrow, that means this step is irreversible in nature. Now, from glucose 6-phosphate, there will be formation of fructose 6-phosphate. And this step is reversible, and there is just the form is changing. So this is a isomerase enzyme dependent reaction. Isomerase. And the another name of isomerase is phosphohexoisomerase. Phosphohexoisomerase. Now, from fructose 6-phosphate, there will be formation of fructose 1,6-bisphosphate. So in this thing, there will be expenditure of energy because one more phosphate is getting attached to the fructose, and this step is actually what kind of a step? It is a energy dependent step that we have seen, and it is catalyzed by kinase. So the kinase is of phosphofructokinase. Phosphofructokinase. And there is lots of importance of this step. This is a rate limiting step, a slowest step. This step, it determines the rate of the whole reaction. So this is the rate limiting step. From fructose 1,6-bisphosphate, there will be 2 products that we will be seeing in the next page. The 2 products which are being formed is dihydroxyacetone phosphate, and glyceraldehyde. These are the things. And the enzyme which is responsible for catalyzing this kind of reaction is aldolase. And these 2 forms, they can also be changed within themselves by the enzyme isomerase. Isomerase will change dihydroxyacetone into glyceraldehyde and glyceraldehyde into dihydroxyacetone. Now glyceraldehyde, it is going to change into another thing that we are going to see, and the thing that you need to okay, dihydroxyacetone phosphate we have written, and here we haven't written glyceraldehyde 3-phosphate. This is glyceraldehyde 3-phosphate. So glyceraldehyde 3-phosphate, now there will be generation of energy in the form of NAD will get formed. NAD will change into NADH, and this NADH is responsible for giving 2.5 ATP to electron transport chain. So this is the thing that is happening, and the enzyme which is responsible for catalyzing this reaction is glyceraldehyde 3-phosphate dehydrogenase. This is the enzyme which is responsible for formation of the 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate. This is the thing. This will be the product of glyceraldehyde 3-phosphate dehydrogenase. Now, this is further going to give rise to ATP. See, ADP is changing into ATP, the very important step. This ATP is forming. So, you know what kind of reaction is this called as? This is called as substrate level phosphorylation, because without electron transport chain, the ATP is being formed. So this is substrate level phosphorylation. So 1,3-bisphosphoglycerate, and this 1,3-bisphosphoglycerate is going to change into phosphoglycerate. Phosphoglycerate. And the enzyme responsible for this reaction is bisphosphoglycerate kinase. So there is substrate level phosphorylation, very important to remember, because this term can come. Substrate level phosphorylation. Substrate level phosphorylation. Then 3-phosphoglycerate is going to change into 2-phosphoglycerate. Going to change into 2-phosphoglycerate. This 2-phosphoglycerate is formed from 3-phosphoglycerate with the help of isomerization reaction, and the enzyme is mutase. So 2-phosphoglycerate is going to change into phosphoenol pyruvate. Going to change into phosphoenol pyruvate. Going to change into phosphoenol pyruvate, and in this there will be removal of water, and the enzyme which is responsible for this kind of conversion is enolase. The enzyme which is responsible for the conversion is enolase, phosphoenol pyruvate. Now we have seen the first step was irreversible, the third step was irreversible, and now the last step is again irreversible. This formation of pyruvate. And this also gives a substrate level phosphorylation and ATP. And it is catalyzed by pyruvate kinase. Pyruvate kinase. This is how the whole glycolysis it occurs. So very quickly we'll just have a look towards the whole steps. So glucose, it is getting converted into glucose 6-phosphate through a irreversible reaction, and there is expenditure of energy in this. Glucose 6-phosphate will change into fructose 6-phosphate. Third step is irreversible. Then fructose 6-phosphate will give rise to fructose 1,6-bisphosphate, which will give rise to dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate is going to change into 1,6-bisphosphoglycerate. 1,3-bisphosphoglycerate is going to change into 3-phosphoglycerate, and 3-phosphoglycerate is going to change into 2-phosphoglycerate. 2-phosphoglycerate will change into phosphoenol pyruvate, and phosphoenol pyruvate will change into pyruvate to an irreversible reaction, which again gives rise to substrate level phosphorylation, that is generation of ATP. So remember these things. Now we also read that this glycolysis it occurs anaerobically. So if it is occurring anaerobically, what is going to happen? It is going to form pyruvate and lactate. So one molecule, okay, we'll take another slide. So if aerobically occurs glycolysis, if it occurs aerobically, one glucose is going to give rise to one pyruvate. Right, because it is the aerobic mode of respiration. Now if it is occurring anaerobically, what will happen? It is occurring anaerobically, one glucose will give rise to one pyruvate plus one lactate. This is the thing. If it is occurring aerobically, one glucose, one pyruvate, if aerobically it is occurring one glucose, two pyruvate. That was the slip of mine. One glucose to two pyruvate, and aerobically if it is anaerobically if it is occurring, one glucose is converting into one pyruvate and one lactate. This is the thing. Now let us have a revision about the 3 irreversible steps, because they are important. 3 irreversible steps. Now if these 3 irreversible steps are occurring, what are they? How we are going to call them? First is hexokinase reaction. Second is phosphofructose kinase reaction. And this step is the rate limiting step. Rate limiting step. And it decides the fate of the whole pathway. Once this reaction has occurred, it cannot go back. So it decides the fate of the whole glucose. And lastly, pyruvate kinase. Pyruvate kinase. So these are the 3 irreversible steps of glycolysis. Now talking about the 2 important substrate level phosphorylation. 2 important substrate level phosphorylation. So whenever I will write here, whenever ATP is generated directly without electron transport chain, is called substrate level phosphorylation. Right, so the 2 places where it is happening is in the bisphosphoglycerate kinase, bisphosphoglycerate kinase, and this step is actually a reversible step. And it leads to production of energy production without ATP. The second step is pyruvate kinase. The last step, pyruvate kinase, it is irreversible. And energy production without ATP. Energy production without ATP. ETC. ATP itself is produced without ETC, without electron transport chain. So this is the thing that we wanted to know in glycolysis. Then we also need to know the regulation of glycolysis. Without regulation, nothing is complete. So we need to know the regulation also. So regulation, how is it regulated? So it is regulated at two places. First is hexokinase step or glucokinase step. So how is it regulated over here? So this enzyme is inhibited by glucose 6-phosphate. Glucose 6-phosphate inhibits it. And this it does in the influence of insulin. Does in influence of insulin. So insulin, it activates the pathway, but glucagon, it inhibits the pathway. Insulin activates pathway. Insulin activates pathway, and glucagon, the opposite, it inhibits the pathway. So the two hormones which are responsible for maintaining the blood sugar level, insulin, it will decrease the blood glucose level. But how? It is going to convert the glucose into energy. So insulin is going to activate the pathway. It will want the pathway to work. But glucagon will not want this pathway to work. It will not lead to decrease the glucose level of the body. So insulin, it activates the pathway, and glucagon, it inhibits the pathway. The second place where it is regulated is in the phosphofructokinase. So what phosphofructokinase does? This is the rate limiting step. Rate limiting step. Now what else? It is activated by insulin. Activated by insulin. And it is inhibited by glucagon. This is the thing. And this enzyme is actually allosterically inducible. This phosphofructokinase is allosterically inducible. Allosterically inducible. So how is it allosterically inducible? It is activated by AMP. Activated by AMP. So there is lack of ATP. So it is activated by AMP. And other thing which activates is fructose. Fructose 1,6-bisphosphate. And inhibited by ATP and citrate. So this is how allosterically it is induced and allosterically inhibited. So if it allosterically inhibited by ATP and citrate and allosterically activated or induced by AMP and fructose 1,6-bisphosphate. So these are the two things which are required for the regulation. Now the third thing which is required for regulation of this pathway is pyruvate kinase. Pyruvate kinase. So it is activated by insulin, activated by insulin, and inhibited by glucagon, and inhibited by glucagon. And if it is activated by insulin and inhibited by glucagon, so these are hormones. How are these hormones going to influence the activity of pyruvate kinase? So it is influencing the activity of pyruvate kinase through phosphorylation and dephosphorylation. This is the strategy how it influences the activity of pyruvate kinase. Now, lastly, the thing which need to be known in glycolysis is the energetics. That how much energy is utilized and how much energy is consumed. So, for aerobically, if it occurs aerobically, what is going to happen? There is generation of 7 ATP. Generation of 7 ATPs. How? Generation of 7 ATPs. So, through 2 NADH, 2 NADH is going to give rise to 5 ATP through electron transport chain. Then 2 substrate level phosphorylation is going to give us 4 ATP. So we are talking about 1 glucose. 1 glucose. So 1 glucose is going to give 5 ATP and 5 ATP from NADPH and 4 ATP from 2 substrate level phosphorylation. And there is consumption of 2 ATPs as well. So consumption of 2 ATPs. Consumption, and here we write production. Consumption 2 ATP. So total 9, and this is, so 9 minus 2 is equal to 7 ATP gain. 7 ATP gain when it is occurring aerobically. And we are also talking about 1 glucose molecule, not less, not much, but 1 glucose molecule. Now when it is occurring anaerobically, what will happen? If it is occurring anaerobically, what is going to happen? This pyruvate is going to change into lactate. Pyruvate is going to change into lactate in the presence of enzyme lactate dehydrogenase. There will be utilization of one energy over here, and substrate level phosphorylation will be same. The 2 substrate level phosphorylation. So the NADH which was produced in one of the step of the glycolysis is going to be nullified from here. So there will be no NADH in the calculation of energy. Just substrate level phosphorylation will be there in the calculation. So 2 substrate level phosphorylation is giving rise to 4 ATPs. So, and 2 ATPs will be utilized also for joining of the phosphate groups. So there will be 4 ATP minus 2 ATP which are utilized, and NADH, why we are not taking its account? Because one of the NADH which is produced in the pathway is again nullified from this place when pyruvate is getting converted into lactate dehydrogenase. So when we are talking about anaerobically, there is net gain of 2 ATP, and anaerobically there is net gain of 2 ATP only. So like this we have seen glycolysis in detail along with the energetics. In the next class maybe we'll be talking about HMP shunt, that is also quite important. So read this topic well, try to understand the places where it is regulated, then energetics and the enzymes which are involved. All these things, they will be very much helpful for you. So try to read it that way. And lastly, please subscribe the channel. Let's crack CSIR-UGC NET and hit the bell icon for getting all the notifications of the upcoming videos. And if you really like my video, give it a thumbs up and go to the Unacademy Learning app. Over there you can follow my profile for more upcoming videos in the form of special classes as well, and on the YouTube. Lastly, do not forget to use my referral code FB01 for getting a 10% discount. If you're using my referral code FB01, you will be getting an additional 10% discount in your Plus subscription. So this is it for now. We'll be meeting again in another class of CSIR Net Life Science with some interesting and important topic according to the examination. This is it for now. Keep on studying and be happy. Bye.